Okay, so this is a problem where it is a horizontal circle. An object moves in a circular path of 17-meter radius with a speed of 23 meters per second. So we can see here that we are given the radius and we're given the speed, and since it's in meters per second, I know that that's a v. So you now have to you have to keep track of what's an angle. If it's a v, you're going to use adjectives usually linear or tangential. And if it's an omega, it's an angular velocity, and so you're going to use the adjective angular. So in this problem, the first question says, what is the object's angular speed? So angular speed means that I'm looking for omega. I'm only going to do it like I'm doing a conversion. Just do it as if you're doing a conversion. So my starting point is I'm going to begin with a velocity, with a linear velocity, 23 meters per second. And I'm going to convert that. Omega has to be in radians per second. So I can do it in one step. So this problem really should only take a couple seconds to get this answer. So you're going to go from meters to radians. Now, 1 radian is equal to the length that I would travel if I were traveling on the circumference of that circle and swept out a 1 radian angle. And that's the radius of the circle. So that's really, by definition, what a radian is as an angle. It's whatever the radius of that circle is, how far do I have to walk along the circle to, and then stop, and whatever angle I've swept out from the center of the circle, that's what a radian is. That's why a radian is a weird unit, because it's not real. Normally we say 60 seconds equals 1 minute. I'm comparing a time to a time. 5 meters is equal, a meter is equal to so many inches or so many feet. But I'm saying a radian, which is an angle, is equal to a length. So that's why it's that fake unit that a lot of times I tell you to just ignore when you're trying to cancel out your units. But in this problem, 1 radian is going to equal 17 meters. So I'm going to write 1 radian and 17 meters, and then work that out, and that's going to be your answer. So 1.35. So 1.35 radians per second. And then part B, it says, what is the time it takes for the object to make 1 revolution? That's another conversion. When they say time, when we're doing circular motion problems, it's always the time for a revolution. So I'm now going to solve for time, and I'm going to begin with the same fact that I had to solve for the angular velocity, but I'm going to invert it because I want the unit of seconds to be in the numerator, not the denominator. So I'm going to write, instead of 23 meters per second, I'm going to write 1 second over 23 meters, because I just now need to convert the meter in the denominator into revolutions, and I'll be done. So I'm going to extend the line, and I'm going to go from meters to revolutions. And 1 revolution, when I do 1 revolution, I move through the circumference of the circle. So what's the formula for the circumference of a circle? 2 pi r. So it's going to be 2 pi, and then the r in the problem is 17 meters. So if you solve that, notice the meters are going to cancel out.
Wait, hold on. So at the end, you divide it by 23?
Right, because that
was what I was really confused by, because at the end I got some really high number for time, and after doing 2 pi r, because I never divided by 23.
Okay, yeah. So when you're solving for time, whatever your velocity is, you have to invert it. But it was 23. It wasn't 1. So that answer came out to be 4.64, right? 4.64 seconds per rev. Okay, now in part C, it says, what is the object's centripetal acceleration? Well, I have 2 ways of getting that answer. I can either use the formula v squared over r, which I can do because I know v and I know r, or I can use the formula r omega squared, because that also equals centripetal acceleration, and I know that because I just calculated it in part A. So to solve for this one, I'm going to have v squared divided by r, and in this one I'm going to have r omega squared. So with the v, I'm going to put in 23 meters per second and I'm going to divide that by 17 meters. And in the one down below, I'm going to have 17 meters, but I'm going to use that omega that we calculated, 1.35 radians per second. And those two they're going to be very similar answers. I don't know how much we had to round off this number right here. So that might be a reason. Like this is going to be the exact answer because they gave me 23 and they gave me 17. But I did calculate that, so I don't know how close the number. I mean, did we have to round that much, or was it almost close to 1.35? Like when we did 23 divided by 17, like what was the full number?
1.3529.
Okay, so we're going a little bit lower than what the full number is if we put everything in. So they might be a little bit different, and I think the answer for this came out to be somewhere around 31.1 meters per second squared. All right, and you have two ways of doing it. You could have used the V and the R or the omega and the R. Any questions with that one? I really didn't need a picture for this one because they never asked me anything about the force. In fact, I wouldn't be able to solve for the force because they didn't give me the mass in the problem. So really, all I could do is, I need to know the mass. They would have had to tell me that in order for me to actually solve for the centripetal force. All set with that? All right.